All right, welcome everybody. Thank you for being here for the first talk of the day. You survived the first day, you survived the first night in Berlin, so that's nice. All right, joking aside, hi everybody, I'm Marco. During the day, I'm an Android developer, and during the night, I like to explore different platforms because it's fun. And for the past year and a half, I've been working on a little side project of me. It's an open source RSS reader hub, which is called FeedFlow, and it's available on Android, iOS, and macOS. And today, what I want to share with you today is the journey that took me to actually release the thing in the store. So all the journey, all the step, all the struggle that I had to deal with. And with that, I hope that is going to be helpful. Maybe if you're going to be in the same situation as well, or maybe I'm going to inspire you to get that pet project that is sitting in the unreleased drawer that we all have, because we just have fun doing it, and then maybe we're going to release it, maybe not. So maybe it could be inspiring for that. Okay, let's get immediately into the things, and let's start by talking immediately about distribution. And of course, I started from Android because, of course, it's the thing that I'm doing day by day, so it's the thing that I know, so it was the easy thing to start with. And I assume that the majority of you here already know how to release an Android app. Are there by any chance anybody that that is not an Android developer here? Okay. We are an open community. We accept everybody, so you're welcome here as well. Okay, joke aside, just to recap the things, all the stuff that you have to do to release an app on Android is actually signing the app, because you don't want to release something in the internet without a signature for security reasons. And then you just need to upload it to the Play Store. Of course, go through all the review and whatever the things that takes a lot of time these days. But let's assume that the thing doesn't exist, and so to just release the stuff, you just have to do these two steps: just signing it and put it up on the store. Pretty simple. Okay, let's now spice things up and let's change platform. Let's go on iOS. And on iOS, it's a bit more spiced up, but the things are pretty similar. So first of all, again, you have to sign the app because you don't want to release unsigned stuff out in the internet. And then there's an additional step that there's not on Android, which is provisioning profiles. And it's basically a required step where Apple verified that the app has been signed with a trusted developer, so with an actual developer that is enrolled in the Apple developer program, and not with just a random certificate that has been acquired and signed your app. So it's an additional security step that is required. And after that, you can just upload your app to TestFlight, and where you can test it on your real device, and then you can go through the review process, the release process that it's on the store, like on Android. But again, let's assume that doesn't exist because it's not the topic of the talk now. And you can all those steps can be done inside Xcode, because there's a little UI there's a UI where you can do the things. Sometimes you just stuck at this loader that you don't know what it's doing. It's like sometimes it's like the Windows update. It's going forever, and what's happening you don't know. But yeah, it's useful because you don't have to care about creating a certificate, upload it, handle it, provisioning profile, stuff like that. Everything is handled automatically for you. Of course, if you're using Xcode, if you're doing manually or on the CI, of course you have to manually handle it. Okay. So very similar to Android, a little bit of difference, but yeah, more or less those are the things that you have to do. Okay, now let's even spice more things up, and let's go on macOS, which is more spicy than the iOS side. Spoiler. And before moving on, a little thing. So in this case, we are releasing a JVM application, a JVM desktop application. So we are not using any SDK from Apple, so no Swift UI, no AppKit or whatever. But it's a pure JVM app. So we're going to use all the tooling from the JVM to sign, release, and do the thing. So we have to take in mind this thing. Okay, there's different way of releasing an app on macOS. The first one could be just having a jar, but yeah, it's not the most user-friendly format for a desktop application, because you're assuming that your user have a JDK installed, which is sometimes it's not the case, and also dealing with jars is not the best app experience. Let's put it in this way. So yeah, it's not a recommended way. The other way is doing a manual distribution, so releasing your app outside the store, so in your, for example, your website or your storage, or with Homebrew, for example. And of course, you can use the App Store for doing that. So like on iOS, upload the app on the store. The thing is that in this case, you can't use Xcode, because again, we are doing a JVM app, so there's no Xcode involved. And in this case, can be either a great news or a bad news, depends on what you like. I prefer doing things manual, and not deal with Xcode, but yeah, that's a preference. Okay. Let's move it up. So for doing a manual distribution, you can already assume what you have to do, and it's signing the app. Of course, you don't want signing is the thing that you have to do in every platform. You don't want to release stuff without doing signing. Then there's another process that is required, which is notarization. Basically, notarization is an additional step that is required from Apple if you're delivering an app outside of the store, and it's basically an additional security step that is required. So in this step, basically, Apple is looking at your binary and to check if it's a malware, basically, if you're sneaking out bad code inside it. Not bad code, but malicious code. And it's also checking that the code signing doesn't have any issues, so that you have done properly with a legitimate certificate. And when you're doing that, you're gonna let know Apple that your app exists. So the gatekeeper, that is the security thing that every macOS has, is gonna know about your app. So it's gonna be happy, and you can install it. If you're not doing notarization, you're gonna have, and you try to install an app, you're gonna have this beautiful error, and you can't use your app because Apple doesn't know about it. He thinks it's malware, so nope. You can disable Gatekeeper, but it's not a straightforward process. You're gonna have to tinker with low-level stuff. It's not recommended to do it because, yeah, it's not the best thing to do. So you're gonna have to do notarization. And to do that, since there's no Xcode involved, you're gonna need to use the CLI from Apple, which is the notary tool. You have to pass some information about it to do that. And you also, and this process is gonna take a couple of minutes. So you're gonna have to wait a couple of minutes until Apple is done with the process. That's why you're gonna pass the --wait thing, because this will pause the execution until Apple is happy with the result. After that, you have, after the notarization is done, you have to connect the information of the result to the binary, so you're stapling the ticket that Apple gave to you, so that the binary contain the information about it. It's a bunch of CLI from Apple, but luckily you don't have to care about it because that's the internal things. And the Compose Multiplatform Gradle plugin has a nice Gradle task that underneath call the things, so don't care about it. You only need to set the information that are required and just call a Gradle task and don't have to deal with strange Apple CLI things. Okay, at this point, after doing the notarization, you're good to go, and you can start distributing your app. And where to distribute is up to you. you can choose an hosting, your website, homebrew, whatever you want. For example, I started using GitHub releases for that, so you can just upload the binary to GitHub releases, and then maybe share the link on your website and stuff like that, so the user can download it directly from there. Okay, now let's move to the release on the App Store, and you may already guess what you have to do as a first step, which is, again, signing the app. And like on iOS, since we are publishing on a store, we also have to do provisioning profiles for the same reason on iOS. In this case, we're gonna need two different provisioning profiles, one for the app and one for the JVM that is gonna be embedded inside your app. Because we are building a macOS app with a JVM, and so we need the JVM to actually run the thing. And we don't want to assume that the user have a JVM installed in their machine, so we need to embed a little JVM inside our binary. And so because we are doing that, we also need provisioning profile for that JVM runtime. So we're going to need a double provisioning profile. And that's it. After doing that, we can just upload it to TestFlight again. In this case, we don't have Xcode as well, so we have to use something else. Luckily, Apple has a nice app that is called Transporter that you can download from the App Store as well. And basically, in there, you can log in with your Apple stuff, Apple credential of the developer account, and you can upload the thing. It's gonna check that everything is all right, and then throw you an error if it's not all right. So I did my first upload. Of course, I didn't expect that to be working on the first run. If things works at the first time, I get suspicious because it's never working the first time. And in fact, I got an error on the first time, so theory validated. And the error was pretty descriptive. Basically, I was only building for Apple Silicon because I'm doing on a free time. Apple Silicon, it's the majority of the market, so I don't want to put an Intel build. But you actually required to put an Intel-based version if you're targeting less than macOS 12, which I wasn't. I didn't thought I wasn't, but actually I was, because the Gradle plugin was, the Compose Gradle plugin was automatically by default setting the version of macOS 10, and you couldn't modify it. So I forked Compose. I did a change, and which was an interesting learning experience to fork the entire Compose thing, Compose Multiplatform thing. And from Compose 1.6.10, you can now modify the minimum macOS version to 12, for example. So you can upload just an Apple Silicon thing and forget about Intel Mac. Sorry, Intel user, but just Apple Silicon. It's enough. Okay. After doing that, of course, the upload went okay. I did the first run of the app, and of course, again, first run, things doesn't work at the first run, and I got another error. And this was interesting because I didn't know about it, and it was interesting to read about it. So basically, it's saying that the native library for SQLite cannot be opened because Apple thinks it's malware. So I started digging around, and I discovered that every app on macOS is running that is released on the store is running on a sandbox, which is a security feature from Apple again that limits the capabilities of the app. So basically, you cannot access every file in the user machine. You cannot access any hardware capabilities. But you have limitation, and you can enable some stuff step by step with some settings. And of course, if you enable stuff that you don't use during the review, during the Apple review, they're gonna shout to you until you disable it. But for sure, one thing that you cannot do is for sure loading arbitrary code from a folder, because yeah, that's what usually malware do. It's just load arbitrary code from the thing. So I was apparently loading arbitrary code, which I didn't know, so I couldn't do it. So why? Well, to understand what things were, we need to understand how native libraries works on the JVM. So, for example, in this case for SQLite, because we need a native library to actually interact with SQLite. So the things works that the native libraries that are required for a dependency. So in this case, I'm using SQLite. So SQLite needs to access SQLite. So it requires a native library. And this native library is usually embedded inside the dependency, inside the jar of the dependency. And when the library, when you're interacting with your database for the first time, and the connection needs to be made, this native library is unzipped, unjarred is the correct word, I guess, unzipped from the jar and put it in some random directory and then load it from the code. Which the thing works without a sandbox because you can do whatever you want. And in this case, the JVM is unpacking the native library inside the temporary directory of macOS, which is pointed by the KMP dir variable that you can type in your terminal. And it's a folder where it's a temporary folder with a bunch of stuff, and it's probably a folder that is wiped out when you reboot your Mac, but that's the place where the JVM put the native library, and it loads from there, and it can load it because you can do whatever you want. On the sandbox, instead, it's trying to do the same, but inside the sandbox, which is something that is not permitted, again. And in this case, the folder is, the sandbox folder is inside your user folder, inside library and containers. If you ever open this library, this folder, you may have seen different folders from every app that you have in your Mac. And those folders are actually the containers of the folder inside the sandbox. So in here, you have the folders that your app can access. And in this case, there's going to be this temporary directory with the native library. And the JVM is trying to load it from here, but no, so Apple says no, you can't from the sandbox. So how to fix this thing? Well, we need to make Apple aware that this native library is not malware. It's something that we control and we want to actually load it. So in order to do that, we have to bundle that inside the binary and sign it. Because if we sign it, then we are putting our mark on it, and we are going to say that we know it's safe. So how to do that? Well, first of all, you have to locate the native library in the transitive dependency that you're importing. So in this case, SQLite is using SQLite JDBC as a driver for accessing it. And if you deep dive inside the repo, you can find the native library for the architecture that you want. In this case, ARM64, because it's an Apple Silicon device. And at this point, you can download it, and we have to place it inside the app binary thingy. So luckily, Compose Multiplatform on desktop gives some possibility to package random resources, arbitrary resources inside the binary. And to do that, we can create some folders with a specific path. We can put inside common, and this will be taken from every OS, so on Linux, Windows, and whatsoever. We can specify the OS that we want, and we can even specify the OS and architecture that we want. So in this case, we can download our we can download our binary, our native library. We can create a folder called resources because naming it's hard and I didn't have many ideas. But the important part is the macOS-ARM64. So the Gradle Compose Multiplatform plugin will know to pick it up when building for ARM64 on macOS. Of course, you need to tell the Gradle plugin that please pick this folder, pick these resources from this folder, so you can do it with the app resources root directory. And then you have also to tell your code to actually load your native library from a specific folder. So in this case, you can check if you're running on a sandbox by checking environmental variables, and then you need to set the path where the JVM can find your native libraries. In this case, I'm setting a predefined path from the library, from the SQLite JDBC library, so it's a custom property. But after talking a bit on the Compose leg, another suggestion will be to just be more generic and just put the java.library path. So for every native library, just pick the thing. I'm still doing it in a specific way. Maybe I'll move to a generic. Let's see how it goes. But it's nice to have both the possibility. Okay, and finally, after all this stuff, I had my app in all the stores, and I was pretty much happy with that. It was a very long process, but it was worth it. Okay, of course. Just putting on the store, it's not the end of the journey. You actually have to monitor if things are working or not going bad. So for crash reporting on the mobile side, I'm using the classic file-based Crashlytics in combination with CrashK iOS from TouchLab for having proper disambolicated Kotlin native for iOS crash reports. And so if you have this library, you go on Crashlytics, you're going to have not just random memory address, but actually the line of code for Kotlin where the things blew up. So you can actually see the Kotlin code from the iOS crash report. Okay, for macOS instead, I had actually no idea what I could use because I never did it. But after some digging, I found out that there's a Sentry Java SDK that it's working also for every JVM language. So I started using it. I'm happy with that. Then I also need logging to check if things are working correctly. So for that, I'm using Kermit, again from TouchLab, which provides you the classic logging stuff with the classic levels like debug, warning, and whatsoever, the usual stuff. But on top, you can also send the logs to some other places. So for example, you can customize your logger. So in this case, you have a platform log writer, which is by default writing on the platform-specific things, so on Logcat, for example, on Android, or the standard output on the JVM. But you can also specify different place where to put your logs. So, for example, I am having a custom crash report log writer, which on mobile is sending the stuff to Crashlytics. And this is coming out of the box from Kermit. You can the support. It's already provided in the library. And for macOS instead, I decided to send the logs to Sentry because I'm using Sentry. But in this case, there's no Sentry support inside Kermit. But you can actually pretty easily write your own log writer because you can extend the log writer class. You need to provide an implementation of the isLoggable function, so to decide which level of which level of logs you want and your own logic to decide if you want to log the thing or not. And of course, the log thing where you will be calling, in my case, the Sentry API, or you can call, for example, I don't know, whatever things you're using, your own backend or whatsoever. So pretty nice. I'm pretty happy with that setup. Okay, last topic for today, it's internationalization. And since it's a multi-platform app, and I forgot to tell you at the beginning that it's FeedFlow. It's built with Kotlin Multiplatform for the logic. It's built with Compose Multiplatform for Android and desktop, and SwiftUI for iOS. So since it's built with this setup, I don't want to share the translation between different platforms. I just want to have it right once, and that's it. And for that, I'm using Lyricist. That is a nice, very nice library for handling translation with Kotlin on Jetpack Compose, but I'm also using with some customization that I'm going to show it to you in a second, also on SwiftUI. I'm not using the Compose Multiplatform string resources right now because it's, if you want to call it outside Compose, you're going to need a suspending function, which is something that I don't want to do on SwiftUI, just handling coroutines for translation. But yeah, let's see how it's going to evolve in the future. But with Lyricist, basically what you're going to have is a map. Basically, it's automatically built by the library. It's going to be a map with your string inside a Kotlin object, and then of course the language code that you're targeting. Then you can define at the root of your app. You can use the composition locals to provide language code that your user are currently using. And so with that, when you need a translation, you can just get the current language and get the current string translated in the current language by just checking the current local composition, which is pretty neat. Okay, for iOS instead, again, we are starting from the same map, and I'm doing some manual stuff. So this is Swift code, so on the iOS side. So in this case, I'm getting the language code of the user when I'm starting the app. So in this case, specifically when I'm starting also the dependency injection, which is Coin in my case, and I'm passing the language code to the Kotlin side, and where the actual coin initialization is done. And in this way, I can dynamically build inside the dependency injection the translated string for the current language in this way. So I can access them on iOS, for example. In this way, I'm of course statically saving that in the app class on iOS, because I don't want to write every time Kotlin dependency.share.whatever. And in this way, I can, when I need a translation in my Swift UI, I can just access that FeedFlow strings and then have the translation automatically done. On iOS, it works that when you change the language, the entire app is rebuilt. So this thing works because if you change the language, the app is restarted from scratch. So everything, including the dependency injection, is rebuilt. So the thing works, and I'm pretty happy with this setup. Okay, we are at the end of the journey. Let's try to find some conclusion that it's just not the list of things that we've seen. And to sum things up, it may be an obvious thing, but it's not. And in general, when you're doing such exploration, such stuff that are not your day-by-day job, start from the stuff that you already know, because it seems obvious, but it's not, again, because when you jump into such things, I mean, for me, usually it's, yes, I want to do everything, and then you just get overwhelmed, and then you can do nothing. But if you're doing incrementally, so for example, you start from the stuff that you already know, so I started from Android, then you move. I was already doing iOS in the past, so I already knew the iOS release process, so I moved to iOS. And then I moved to macOS because it was something that I never did it, so it could be interesting. I did it outside of the store, because when I did what you have to do for the store, I was, okay, no, I wasn't gonna do it now. But then after a year, I was, okay, now I want that as well on the store, so let's find out. Let's cry for a couple of weeks until I figure out how to do it. But at least if you do it incrementally, it's gonna be nicer. And finally, to just wrap it up, why doing all of the things? It could be a fair question. But the thing is that just in general, exploring other stuff, exploring other things, other planets, other platforms, whatever different from your comfort zone and from your day-to-day job, it's something that really enriches your vision. That it's something that I really suggest you doing, because it enriches your knowledge, enriches also your vision of stuff, because you're just seeing different things. You're not stuck in your own little bubble that maybe it's comforting, but it's if you can just explore different things, which could be nice, and maybe can give possibility to open some other possibility here and there. So yeah, it's really something that do it if you can. Okay, before wrapping up, of course, I showed you all the steps manually that you can do it, how things works, how things not works, but at the end of the day, I'm just a lazy person. So a lazy developer builds automation, usually actually spend more time building automation that can done in less minutes, but it's fun. So all things to say that all the steps that I showed you today, I built it for GitHub action, basically. So I can just push a thing and then just push something, and everything's going to be automatically handled. I didn't put on a slide because it's boring configuration, but if you're interested about it, I wrote a bunch of articles on my blog, so you can check it out and you can replicate the thing because it's also open source. And funny thing, I got one of the certificate for iOS or macOS. It's expiring in 2 weeks, I guess. So it's gonna be fun to set up again. Let's see how it goes. If I'm gonna cry on Twitter, you're gonna know that it's a painful process, but I hope not. Let's see. Okay, that was it. Thank you very much for the attention. If you have any kind of question, you can share it out. Otherwise, I'm happy to chat about. You can find me around. I'm happy to chat about multi-platform and all those nice things that you can do it. Thank you.